Okay, so we're going to have a group of 30 people, and they are selecting four of among the 30 people to embark on a mostly voluntary one-way trip to Mars. How many different groups can be selected? So that's kind of our A1. We're going to have B, C, D, E. So we have 30, and we're selecting 4 of them. So the order doesn't really matter. So that's going to be a pretty straightforward 30 choose 4, which is 27,405. Okay. B. So let's say now we're still choosing the 4 reps, but Zach must be chosen. So I'd pause the video and try to figure it out yourself. I'm not going to pause it. I'm going to sally forth. So we have the 4 people who are going to Mars, but Zachary is taking up one of the spots, so I'm going to put a box around him because he's not changing, which means we only have 3 spots left. Now, of the 30 people, one of them has been chosen, so there's only 29 left. So in this case, it would be 29 choose 3, which is going to be 29 choose 3, which is 3,654. So 364 of the 27,000 ways, 3,000 of them or so have Zach, or he must be chosen. Now let's say we have Juliet must not be chosen because she's important for some reason. So I'm going to show you how I'm going to draw this one. So I would pause it and try it yourself. So we have our 4 spots, and where Juliet is going to be, Juliet is not one of these 4. So Juliet actually is guaranteed to not be one of those 4. So Juliet is going to be, so there's 29 people, but now we're choosing 4 of the spots. And 29 choose 4 is 23,751. Okay, now let's say, let's have a D here. At least one of Zach or Juliet must be chosen. Okay. Now, we're going to do this. I'm going to show you 3 ways of doing this. So we're going to call the first one method 1. I thought of that name all by myself. So method 1, we're going to look at these 2 cases. So either Zachary is going, or Juliet is going, or both of them are going. So we've already done this one. If Zach has to go, that's going to be, let's put a different color on it. That's going to be 29 choose 3. That's going to be 29 choose 3. And this one's going to be 28 choose 2. And it might be tempting to just add up those cases, but that'd be wrong. I'll quickly show you why it's wrong. You don't have to write this down, just take a look. So these are all the times where Zach is going. These are all the times when Juliet is going. So if I add up all the times that Zach is going, I've added up these two areas. If all the times Juliet is going is these two areas, and all the times they're both going is this. So what I've done is this is the Zach not Juliet, the Juliet not Zach, and I've added the times when they're both going 3 times. Because if they're both going, that's included in the 29 choose 3. It's included in this 29 choose 3, and it's included there. So that's not going to work. What I want to do instead is so we have the Zach and the Juliet. So what we could do is we could add the Zachs. We could do the Zachs plus the Juliets. So with the Zachs plus the Juliets. But now we've double counted this twice. So what we're going to do is we're going to subtract the Zach and Juliets. And if we subtract the Zach and Juliets, then we're getting rid of the doubling. So in particular over here, how it ends up looking is we're going to go 29 choose 3 plus 29 choose 3 minus 28 choose 2. So 29 choose 3 plus 29 choose 3 minus 28 choose 2. And it's going to be 6,930. Okay. So that was method 1. Okay, but if I'm going to give a name to it, method 1 would be direct with overlap. Direct with overlap. So what we're going to try to do now is I'm going to try to do, so method 2 is going to be I'm going to do direct with no overlap. With no overlap. So how am I not going to do overlap? So when I'm setting this up, I have my 4 slots. I'm going to say, okay, I want Zachary on and Juliet not on. So Zachary on, Juliet off. Juliet on, and then Zachary kind of off. And then the last one is going to be Zachary and Juliet both on. So what I've done there is I've said, okay, if Zachary's on, Juliet's off, there's 28 people left. This would be 28 choose 3. This one would also be 28 choose 3, and this one we already know is 28 choose 2. And there's no overlap, so these we can add up. If I was going to draw these out, it would be Zachary, no Juliet. Zachary, but no Juliet is over there. Juliet, no Zachary. Juliet, but not in the Zachary. And Juliet and Zachary is that. And that gives us what we're looking for. So if we add these, so what we're going to do is we're going to go 28 choose 3 plus 28 choose 3 plus 28 choose 2, which is 28 choose 2 is 6,930. Which is kind of neat. It worked out to the same thing. That's kind of cool. But I said 3 ways. So method 3 is going to be indirect. So indirect is going to be, we need our total and we need our bad. So our total and the bad. I'm going to run out of room for this, aren't I? Okay, we're going to do this on another piece of paper. So what we have is, we want to figure out the total, we want to figure out the bad, and that's going to leave us with the good. So the total is going to be the number of people that we could choose. So the total is going to be just selecting any group of 4, and that's going to be 30 choose 4. What does a bad one look like? So a bad one is going to be one where So what we want is we want at least one of Zach or Juliet to be chosen. So bad would be that neither of them is chosen. So the only way to not have at least one is for both of them to not be chosen. And the number of ways for them both not to be chosen, so now that's going to be 28 choose 4. And so the good is going to be the total minus the bad, which is going to be 30 choose 4 minus 28 choose 4. 30 choose 4 minus 28 choose 4, which is, again, 6,930, which is kind of neat. So all these three ways give you the exact same answer. It's probably good to be able to do at least two of them. You probably don't have to know all three.